This is something I call a boring talk, because I'm not going to talk about ideas. I'm not going to talk about lots of things. I'm going to talk about the way we have it in Magiclab, about the way we build our data platform. So this is going to cover the biggest decisions we've made and reasons behind those decisions, and a few other things related to how we gather, collect, and build statistics in Magiclab. So I'm a lead data engineer in Magiclab. Our team is responsible for the framework I'm going to talk today about. So basically that's all the data we have. So in the beginning I have to talk about Magiclab first. So Magiclab is a relatively new brand. It's a company building dating apps. So those are the biggest ones we have. Badoo is traditional dating social network. Bumble is an app where women get all the initiative. Lumen is for people over 50. And Chappy is a gay dating app. So we're all about social networks, all about dating social networks. So let's talk about what we do as data engineers in Magiclab. First of all, of course, Magiclab is about users. Now, what we do is we are trying to understand how users use our apps. So for that, we have to inspect user behavior. So we have to collect some kind of data and make conclusions from it. And what's more important is we are building reports and reporting to decision makers, which make new features and make decisions about features based on the data we provide. So basically this is what we do. Now the only problem with that, we could have just installed Postgres SQL and built some simple UIs based on that, but we have lots of users. Now those are of course registered users, not active users. Active users are more like, I think right now there are about 100 million active users, monthly ones. So what this means is that we receive about 30 billion events per day, and that number is growing. And they sold us for about $3 billion 3 days ago, which came as a shock to everybody. So I guess that says that we are doing something right. Those events result in 2.5 terabytes of data per day, which we store. And in total, right now, we have about 3 petabytes of data stored in Hadoop. This is like, I think that's 2 years of data, describing everybody does in all the social networks we have. So this is a challenge, right? So, and what I'm going to talk about is how do we build up an infrastructure to handle all of that. So I'm going to start with like an empty slate and going to end up with something like that, piece by piece. So let's start with the top-down view. So we have data, right? And we have some kind of presentation. We have to present it somehow. Now, the first thing I want to talk about is what is data for us. So like I said, we have users. And we need to collect facts describing what users do at the social apps. Now, users change the behavior. So all those facts, they only describe those users at a given point in time. And this is exactly what we call events. Now, so technically speaking, every event is a timestamp with some kind of generic metadata attached to it, saying that this event comes from the given brand, on a given platform, from a given version, and so on. Now, what we also have is an event type, which is basically saying what kind of property are we going to expect from that event, and they're going to be present all the time. This allows us to build up schemeful data and very useful in general. So data is no longer data, it's events we receive. So let's update the plan. Now, what's very important, we have to know who defines events. Now, the whole thing starts with product managers. They need to come up with features. And based on those features, they have to come up with, they request some kind of statistics. So the request goes to product analysts, which defines statistics in terms of events. For that, they have to either add new events or reuse older ones. So I'll talk a bit more about that. So analysts add or change event definitions through UIs we provide as data engineers. Now, what this UI really is just a config editor, right? So there's a config behind it all that has all the events, all the data that is going to be sent or received. So the config itself is just a very, very big YAML file, right? So, and this is the interface we use to edit the config itself. So you can see the event type on top with a small description, some properties with event property types, and also descriptions and names, obviously. So this is how they define events. Now I'm going to update the plan a bit. So we have PMs, PAs, and the config. And the next question is, how do we get from the config to events that are sent? Now, what happens really is that the config is converted to a Prada file, which is loosely based on the Google Protobuf format, which is platform independent. So we can propagate that to all the client code we have, to all the different repositories. And client devs take those Prada files and generate event sending APIs. And those APIs that later are used to implement the event sending code at proper places. So here we go. We have the config propagated to all the platforms, and then all the events are sent as plain JSON, right, to the servers. So I'm going to update the plan. And the next question is that when you have like 30 billion events, you cannot just send them, receive them, and insert into a database immediately. You have to do something else. You have to load balance that thing. So roughly speaking, this looks like the following. Like, events arrive at endpoints, every event gets assigned a unique ID, and then gets submitted to something we call a live streaming daemon, which is a load balancing framework we use. It's in-house, but it's open source, so you can check it out. So LSD handles load balancing, event deduplication, and final delivery to the data clusters we have. And this leads us to the next question, like, we receive all the data, how do we store it? So the first thing we do is we batch those events into jobs. Every job gets a unique job ID. We do some basic event schema validation to make sure we don't receive invalid events or I don't know, some kind of broken data. And then we store that into HDFS. So I'm going to add HDFS to the plan. This is crucial. This is kind of like the first thing that happens within the cluster. So this leads us to the next question. HDFS is all good and fine, but you need proper ways to access all of that data. So for that, the first thing we do is convert all the JSON files into the optimized row columnar format, otherwise known as ORCs. We register those files with Hive, and this gives us slow SQL access to all the historical data we have. Basically, this looks like a single flat table with all the events we ever received, well, for 2 years. So we install Hive alongside HDFS. But there are a few more things here. Now, we have many external systems, like data science systems, anomaly detection systems, we have UIs built here and so on. So we need a way to transform the data. We need a way to build up all those indexes. So for that we use Spark, which is good because it gives us access to all the data we have in Hive. It allows us to transform data using both HiveQL and general purpose language with all of its power and weaknesses. And also what's important, we have lots of things happening in the cluster. We also get to do the granular cluster resource allocation. So this is crucial for us, and we use Yarn for that. Now, so Spark works alongside Hive on HDFS, and all the transformation that happens within the cluster happens using Spark. Now, the next beat of the framework is that we have to manage all those pipeline steps somehow. So we need a workflow manager, right? Most people would probably use Apache Airflow nowadays, but because the systems, we started building the systems 13 years ago, we had to come up with a custom solution, which is called ZCube, an in-house tool. Well, it's both similar and different from Apache Airflow because instead of writing Python code, we just write a single config file, YAML again. Unfortunately, we love it. And every transformation we have, every stage of the pipeline we have goes through ZCube. So finally, we have the data, but at that stage we already can inspect the data, right? So we came up with a few technical interfaces, which are based on the data we have in Hive. So in general, this works like the following. We generate some kind of indexes or load some data into an external database using Spark, and we start building UIs on top of it. I'll show you a few examples. Like this is the simplest one. This is basically an event counting interface, so you can group data, you can see how many events you received of a given type, or you can filter them or group by available properties. The next thing, it's something we call funnels. So, for example, if you can define a funnel in terms of events that happen to a user, you can actually see and compare different funnels here. So this particular funnel is a payment funnel. So it's defined in 3 events: start payment, click buy, payment result. But some people somehow drop off. So we want to see why they drop off and how many of them do it. So this allows to investigate those things. So here you see we define it in terms of a start payment event. Next thing I want to show is something we call session search. So for example, let's say we know something's wrong with one of the apps, right? So we want to find all the sessions that have 2 events in them. The first event, app start, and we want one of the following events is app crashed. So we specify that, and we end up with all the sessions containing this pair of events, and we can inspect them in terms of events, which is very useful when we do investigations. So I'll add the low-level UIs here. Those are mostly used by engineers and analysts, right? It's not a reporting tool because most of the time, people outside of the department, they don't understand events, they don't care about it, so low-level UIs are not suitable for them. I'll get back to that later. So we have slow access to all the data, but sometimes we really do want a better tool for that. We need faster access, but to a subset of data only. So we decided to go with Accesshole, which is a proprietary database, but it has very good ANSI SQL support, unbelievably good. Believe me, I was skeptical about the database. It's distributed. It's in memory most of the time. It's columnar, so it supports very fast and efficient analytical queries. And because of good ANSI SQL, it also has efficient joins, which is a rare thing, especially in open source databases. So we can merge different kinds of data, events, and external kind of data within the database, and we do it really efficiently. So for most ETL tasks, we use Accesshole. So I'll add Accesshole here. Right, the schema is growing. Like I said, we need some kind of a high-level reporting tool, which is not defined on events, but defined in terms of aggregate statistics. So we decided to go with MicroStrategy, who have a stand here. They're very good at what they do. They have numerous ways to present data. They're relatively speaking customizable. And they can use Accesshole as an underlying storage. So we have a couple of engineers working on that daily. And I mean, I think products really do love MicroStrategy. So we're probably going to stick with it. So I'll add that. Well, basically, roughly speaking, that's mostly it. If you talk about the framework itself, but there are many other secondary systems, like system responsible for loading more data into Accesshole and joining with the event-based data. So there is a very interesting anomaly detection system which uses machine learning methods for finding anomalies in incoming data. There are other databases, most notably ClickHouse, and numerous small MySQL instances. And there are notebooks analysts use daily, like Zeppelin or Jupyter. Data scientists, analysts, they love them. So let's do a quick recap of everything I mentioned here. So it all starts with product managers requesting stats. They talk to PAs, describe what they need, and PAs start tweaking the configs. The configs are propagated into all the client code we have, and the APIs are generated. They start sending the JSON. As soon as possible, we load the JSON into HDFS, convert it to formats suitable for Hive and Spark transformations. We provide the UIs on top of that, custom ones. Then we convert the data and load it into Accesshole and present using MicroStrategy. So that's the big plan we have. So that's it from me. Thank you.